Hello and welcome to Engineering 133 LC5 Team 12's Image Processing Project. Image processing is found in all aspects of engineering. For example, it's used in the medical field to enhance scans, whether that be MRIs, X-rays, and so on. Another example of medical imaging is in electro-optical technology research, as well as other growing fields of research. Image processing is also found in artificial intelligence that includes autonomous vehicles. Specifically, you can find it in lane detection, traffic sign detection, speed bump detection, basically anything road and surrounding cognition. The basic process of image processing begins with grayscale. So here we have converted the image first into an array. Then the array has a RGB standard weight equation applied to it. This basically means that the red, green, and blue components are all multiplied with a given constant that is predetermined in a set equation. And then all of these components are then later summed, and it is saved as a grayscale image.
Okay, so next with the image blurring, what we do is we first create a 3x3 matrix as seen below on the right. And we also take the array of the grayscale image that was created in the previous step. And what we do is we create a for loop that is used to run or create a 3x3 matrix and applies that matrix around each separate pixel throughout the grayscale image, except for the very edges of the picture. And then we multiply this 1 by 1 matrix into each separate matrix that we create. And it's multiplying by 1, so it stays the same, but then we take the average, which just averages the color of that center pixel and all the surrounding pixels, which just averages the color of that one pixel. And then when averaged throughout the entire picture, it just creates a lower resolution picture, which has the effect of being blurred.
Our next step would be the edge enhancement. We chose to do Sobel edge enhancement over other methods such as Laplacian edge enhancement because it's less sensitive to background noise that might be caused or left over from the blurring step. And this method essentially just applies 2 filter matrices to each set of each 3x3 kernel of an image in the same process that's done for the blurring step. And these filters essentially quantify the gradients across a pixel, and then they're used in this equation that you see below. This equation calculates the magnitude of the gradient, which is then accounted for in the code so that it allows you to have the image that you want before you go to the thresholding step.
So for our thresholding function, we decided to set our threshold value to the average value of the matrix. We did this to ensure that the threshold value is based on each image individually. So then we don't have to manually come up with a new threshold value for each image. We decided to use the numpy.where function to simplify our code because it is essentially a for loop and if-else statement combined where you input a condition. So for example, ours was if the value of the matrix is less than the threshold value, then the function will yield a value of 1. Otherwise, it'll yield a value of 0. And it goes through the entire matrix and finds all values that satisfy this condition. And of course, gives it a value of x or 1 if it does satisfy the condition, and gives it a value of y or 0 if it does not. So now we can go through, and I will pull up our code here. So here we have our code. I have our main function here at the bottom. First, what we do is we accept the user input file name, which then gets read here. the most important part of this main function is that our code only accepts PNG files. So we have an if-else function that determines whether or not the file is PNG, and if it is, it'll go through and run through our entire code, and if not, it'll print an error. And as you can see here, we have our grayscale function, our blur function, our edge detection function, and our threshold function. So I will go ahead and do an example here for you. And it will. All right. So here is our original photo, which we then put through the grayscale function, as you can see here. Next, it goes through a blurring function, which lowers the resolution of the photo as depicted here. Then it goes through the edge detection function as displayed here. And then finally, we have our final black and white photo. I'm going to go back to the code over here. And we will run the code again, this time using a JPEG file. And as you can see, because it is not a PNG file, it prints an error. And I will do one more example here for you. There you have it. Thank you so much for watching our presentation.